This is LeetCode problem number 16, and you can see the problem is 3 sum closest. Okay, so you can see this is the variant of the last problem that you already solved, and the name of the last problem was 3 sum 0, right? So yeah, you can refer the last problem. I'll provide the link in the description. Okay, so basically we have said that we are given an integer array of length n, and we are also given a target. Okay, and we need to find the integer, basically 3 integers in that array such that the sum is closest to the target. Okay, so basically we need to find 3 elements from the array such that the sum will be closest to the target. Okay, and we need to return the sum of these 3 integers, and basically we may assume that each input would have exactly one solution. Okay, and you will able to understand with this example. So this is the array and this is the target. Okay, if you notice carefully, this is the 3 elements that will provide the sum 2, and you can see the difference is nothing but 2 and 1. The difference is nothing but 1. Okay, so for the difference we need to take only the absolute value. So you can say the absolute value of 1 minus 2 will be nothing but 1, so difference is 1. And for this array, this will be, this 3 element will give us the closest sum, so that will be nothing but 2, and we need to return this 2. Okay, now let's analyze these two examples to find the optimal solution. Although you already know that we need to apply the two-pointer approach for this problem also, but there is a slight minor difference we need to use, and we just need to talk about that minus difference that we need to apply for this algorithm or this problem. Okay, so this is the problem, and you can see this is the array. Okay, so this is the array and this is the target. So what I need to do, we need to find 3 elements from this array such that the sum will be closest to the target. Okay, or we can say, we just need to find the difference, okay, between target and sum that will provide the minimum difference throughout the process. That will be our answer. Okay, okay, that will be our answer. That is the thing we need to take care for this problem, and otherwise everything will be very similar. Okay, as we did in the last problem, we need to, first of all, you can see this is not sorted at all. We need to sort this array first of all, then we need to iterate through this array using a loop, right? Using a loop, then we need to use the two-pointer approach to solve this problem. Okay, but everything is similar, but the thing we need to apply is we just need to take a variable that will be nothing but minimum difference. Okay, this will be the global variable, so that we can track the minimum difference throughout the two pointer process. And finally we need to return the sum of the 3 elements that will provide the minimum difference, okay, throughout this process. Okay, and basically everything will be same that we already discussed in the last problem, so I'm not gonna discuss this with detail. Okay, if you are not familiar with that, then you can definitely refer the last problem. I'll put the link in the description so you can watch that. Okay, so now let's jump towards, now let's jump back to the code so that we can code the approach. Okay, so here we just need to take this minimum difference. Okay, so this will be the thing, okay, that will be basically the difference from the last problem. Let's jump to the code section and discuss the approach. So basically what we need to do, first of all, we need to sort the array. So arrays dot sort, we are using the inbuilt method, sort method, and we need to pass the array. Okay, it will sort the array. So then what I need to do, you already said that we need to have a global variable that will, so that we can track the minimum difference throughout the process, right? So that's why we'll be taking an integer variable. Name will be nothing but, let's say, minimum difference. Okay, minimum difference. And basically we need to store the minimum difference. That's why first of all we need to initialize this variable with maximum possible positive value. Okay, and in Java we have such variable like integer. We can use integer dot max value to initialize that. Okay, so and we'll be doing the same. Okay, we'll be using integer dot max value. Okay, max value. Okay, now what I need to do, we need to iterate through the array, and we'll be using for loop. Int I equals 0, I less than, and I will be less than nums dot len. Okay, nums dot len minus 2, nums dot length minus 2. Now you can ask me why minus 2, because we need to find 3 elements, and basically with the help of I, we are pointing to the very first element, and for the rest of the 2 elements we are only can go up to length minus 2, right? Yeah, basically everything we discussed in the last problem, so you can refer that. Okay, and every time we need to increase the I. So in between this loop we need to use two pointer approach. For two pointer approach, our first pointer, that will be, let's say, P, and it will start from I plus 1 position, and the last pointer, let's say Q, will start from last position of the array. So that will be nothing but nums dot uh, length minus 1. Okay, nums dot length minus 1. And for the two pointer approach, you already know the condition will be nothing but while our P is less than Q. So while P is less than Q. Okay, and in between this we just need to apply the method, apply the two pointer approach. So what will be the approach we need to follow? Okay, we'll discuss in the last problem. Let's say first of all what we need to do, we need to find the sum, and the sum will be nothing but the sum of these three pointer value. So let's say name will be sum. Okay, so basically what I need to do, we need to add nums of I, nums of P, and finally nums of Q. Okay, these three variable. Now we already said that we need to track the minimum difference throughout the process. So to track the minimum difference, we first of all we need to find local difference for every iteration. So let's say local difference, and local difference means what? Local difference is nothing but the difference between the target and the sum, right? So local difference is nothing but target minus sum. Okay, as simple as that. Now I said that I just need to check whether this local difference, we just need to keep maintaining this minimum difference throughout the process. That's why first of all we need to check whether this local difference value is minimum compared to the minimum difference or not. Okay, if this local difference value is minimum, then we need to store this minimum value in this minimum difference, right? Now let's check this out. So if and yeah, there is a thing right now we just need to talk about, right? Okay, so the thing is basically we just only need to care about the difference value, not about the signature, right? So that's why we need to use the math dot absolute value. So you can see here, while we are finding the local difference, okay, if some point our sum is greater than the target, then this value will be minus. Okay, and if this value is minus, then it will always take the minus value. So for the difference value, we only need to care about the value, not the sign, right? That's why we need to use the math dot absolute method. Okay, so we'll be using that. Okay, math dot absolute, then we need to pass this local difference. Okay, so as simple as that. Now we need to check whether if this is less than the minimum difference. So again, math dot absolute value of minimum difference. Okay, my bad, the spelling is bad. ABS. Okay, and we need to pass the minimum difference value. Okay, so minimum difference. Okay, if this is less, then what I need to do, if this local difference value is less than this minimum difference, then we need to put this value into minimum difference. So our minimum difference value will be, in that case, will be nothing but our local difference. Okay, as simple as that. Now we just need to think three condition about this local difference value. Now you can see this local difference value, we are getting this local difference from target minus sum. Okay, so this value can be 0, okay, can be greater than 0 or can less than 0, right? And now we just need to handle these three cases. Okay, so let's say the first case will be our local difference equals 0. Okay, now let's think about, like, if the local difference is 0, then what will happen in that case? Okay, so you can see we are getting the local difference as the difference of target minus sum. Okay, now if the local difference is 0, that means the sum will be exactly same as the same as the target. Okay, so we can say we got the minimum possible difference. Okay, or we can say we got the exactly same sum that is exactly equal to the target. So in that step we can directly return the value, because this is the minimum possible difference we can achieve. Okay, that's why we can directly return the value. And so we need to return the value, and the value will be nothing but sum, because we are already set to return the sum of these three integers, and you already stored this variable for this three sum, so we are returning the sum. Okay, Now let's talk about the other two cases. So else, what will happen else if, okay, if this local difference is greater than 0, okay, local difference is greater than 0, in that case what I need to do, okay. So what is our motto? Our motto is to minimize the difference. Like, minimize the difference means we need to, we need to achieve as close as 0, right? So you can see if the, local difference is greater than 0, that means what? That means our local difference is minimum 0. Okay, that means if we want to minimize this local difference as close as 0, we need to, increase this sum value. Okay, that's why. And if we want to increase the sum value, basically we need to nothing but we need to increase the p pointer by 1, because the array is sorted from left to right, the value will increase. That's why we are doing this. Okay, and what is the other rest? What is the only one case we are getting right now? So we'll be having only one case, that is nothing but our local difference is less than 0. Okay, so in that case what I need to do, we need to decrease the sum. So to decrease the sum, simply we need to, reduce the q pointer by 1 place. Okay, as simple as that. So this is basically the whole code, and finally when we will be out of this to loop, we just need to return the results. And what is the result? Basically we need to return the sum that will be close to the target. So now you can look at this equation. Okay, so from this equation you can able to, you can able to find that the sum is nothing but, if we take the difference between target and minimum sum, that will give us the sum, right? So we just need to return target minus minimum sum. Okay, minimum difference. So that is as simple